Now, before we start, I want you to imagine you have three buttons. That's your input. Each button has a number. Maybe it's how bright, how heavy, how loud something is. So your input is like brightness, weight, loudness. Now, the hidden layer has two little helpers, two hidden neurons. Each helper looks at all three buttons and says, based on three numbers, should I wake up or stay asleep? They do that by mixing the three inputs with their secret recipe of weights. If their mix turns out positive, they wake up and say, I'm on. If it is negative, they say nothing. ReLU makes it 0. Now we see the weights. You see, I say weights red box, blue box VS boxes, and this one is activation. I can like this so you can understand. Now, as you see, this is what I mean. We started with 3. For example, we tell like 2, 1. Think like we have cat or cat, fox, and a mouse. Then we assign bias value, weights, like as you also see in other page. I may get some yeah. So this is a formula you add. How can I? Maybe I can make you. Yeah, let's go to the second page. We need to actually make a small numerical example to show you the concept better. Okay, now we have a input x. I hope we are recording. Okay, microphone is on, nice. Let's say 1,2, 8. And you can even say they are like represent word. Think like you can say x1. You can say how positive the word sounds. By the way, you can find the PDF in the description. x2. How common the word x3. How long the word is. Yeah, so this is like given these clues, is the hidden word likely to be happy or sad? Like what the hidden layer does is there are two helpers. Like hidden neuron B looks at all three clues, so this all three clues, and say if the word is short and common but not positive, I should light up in the numbers. Yeah, it got something blah blah. And hidden neuron 2 looks for different paths, like this is our characters, thing like they are characters in a game. These hidden neurons. Hidden neurons 2 looks for different pattern. Maybe is the word positive and common. It got, for example, it got z equals 0,1 equals a tiny positive. Then weak yes, it's a tiny positive. So, but the output can combine also the two options. For example, we say it like we say it hash helper 2 little yes H1 says nothing. Then we say, with these features, I am about 48% sure. 48% sure. The word is happy. Because we say x1, x2, x3, there are clues about the word, h1, h2, two little fillers that sense patterns in those clues. And the vector is 0,48 is or the percentage. The final guess may be happy, but not sure. I want to also show you the numerical steps behind it. Let's say x and we have hidden weights. This is 5. We have biases, very important. And we have output weights. This is our output weights. Don't forget, sometimes even I forget. This is 2 and bias automatically gets 0.5. And if we calculate Z1, you see V1 and X1 plus V1. So it's supposed to be 1. This is H1 max and 0, which I told before. 2 this is 4, this is 5, this is 4. This is bias leave this one, second bias layer. And this is a little sure, which I told little yes. So we say 48. And this is 0, yes, now how we found the 48? It's this is what you wonder, how, like, this is actually gives us how should the model, but how you found the 48? Let me show you this as well. I try to be quiet because my cousin is sleeping in the room. But he concerta maybe is awake. Now we got all the formula. You can make the video a little bit big. Like, it's actually from Sigmoid. Like a Sigmoid. Maybe it's 3 AM and you're watching this video for no reason. It's like I pre-calculated it. We put all values. Like helpful 1 was 0,1 because higher 1 was 0, higher 2 was it's like sleeping, and this quietly awake. Each of you gets a screen card, a weight. Multiply your number by your card, and I will add a mega bias and test the total. So helper 1 got 0,7. But let's wait, let's solve it for we have this blank coded template like x1. I wanted to actually hold for here, and red are the weights, like they are the weights which is in the formula, and blues are the biases which we add to the weight. We are adding it, biases, and green are the activations, outputs you compute to node values. I also open it actually. It's sometimes our topic. Green are the where is it? Yeah, this hash, like this is what actually we are telling all the time. Like they are the live values and not produced during the forward pass. Yeah, like there is always each node, and you first get a pre-activation, draw weighted sum, and plus bias. Like this draw weighted sum plus bias. And forward pass is you pass your input through to network pass to get an output. So basically my brain is sometimes not working. I know. Green numbers are the leave values and not produced during the forward pass. Maybe you can fit x1, x2, x3, the hidden neuron, multiply those by its red. Yeah, like it multiplies by its weight, and add the bias to blue. Then applies the rule like ReLU. We say here the rule ReLU. You can develop your own rule, and the number gives the output maybe 0,1. Yeah, like here's expensive example. Like we do this all the matrices we did before. I was trying to show, but I was very messed up. Like we have okay, I hope you passed to this part, because otherwise I would have to cut, because I'm thinking actually how can I describe you this part. Like this was the output I showed, and like actually we are trying to representing with colors all the matrix step we did, all the neurons here. You can assume the linear algebra you learn is actually like part of neural networks. Yeah, this is the calculation I was going to do. For example, forward pass. Like we have input x1, x2, x3, hidden neuron. This is a hidden neuron. They are hidden neurons. Hidden neuron 1, hidden neuron, hidden neuron 1, 2, 3, 4. Distinct layer, 6 layer, 6 thing like 6 layer. Hidden neurons. Like it's just illustration. It's not very true. So like I will say maybe 6 dimension would be more suitable actually. And this is our output node, only one. They compute how sure they are, and we get their approximate. And there is one guardian test can step optional training. I will pass this step because I will put the PDF in the description so you can open and get this step. And it's same, just showing more and more. This part I also showed. Here we can get more or ReLU and everything. This one would get your attention. Word-based Cloze expensive. Now we have F1, the word before the. So here is F1 and here is F2. So we need to say F1 can take like cat, dog, fox. Can say F2 can get like run, stay, fast, slow, normal. Yeah, like from the subject, what is the subject? Subject, dog, verb is run. Like, you know that F1 is a subject, F2 is verb. And here is all the weight-based calculations, like we do all the mathematics I showed above, and now we see that like we get 3 output because it was 2 to 3. You give 2 hash 1 and 3x, 1x, 2x, 3. We say for them, we say like p dog, p cat, like 3. Yeah, basically 2 to 3. You see here as well. 2 to 3. It will be backward pass, but we are doing here forward pass. Like it will be also wrong. Like I'm not even sometimes I'm not totally sure, so you should verify what I see sometimes. And this is like visualization. Like we have weight dog, weight cat, and weight man. We have the BS layer, and we select for this one dog because it was the highest. And for the blank 2, we select quickly, slowly today. We do the same thing we did. And here what wins, quickly wins. So what this would be, the dog runs quickly. And this is a test for you. You can do it by yourself. Today the blah blah will blah blah at the blah blah. So you can fill the blanks and comment so I can see.